I'm getting half of what they have given.
Okay. So what they're asking, by the way?
They're asking the maximum magnitude of force, which
Yeah.
does not bring slide.
Understood. You can do. This is the question, right?
Yes.
Now, once you try to turn this object like this, the bottom will try to go backward, right? The tendency of bottom is will be to go
Yes.
backward, so friction will act forward.
Huh.
So if you do the FBD, this is friction, and because they are asking the limiting case, can we just write us into it,
Yeah.
and the n is like this, and gravity is like this.
Yes.
These are the only forces acting, right? Now,
Yes.
if you write the torque about center of mass, let's say, or the best thing is bottom. So torque about the bottom. It's a pure rolling condition. We can just write this equals to I about bottom into alpha. Just one line equation.
Yeah.
And why I'm choosing bottom? Because the normal and friction will cancel their. I mean, will have no effect on the torque, right?
Yes.
So F into R. And what is this? Disc cylinder. What is this? It's a cylinder.
MR square by 2.
M square plus M square
Yes.
into alpha. Correct.
Yeah.
So F turns out to be 3 by 2 into M into ACM, because alpha becomes ACM, right?
Yes.
And this is the torque equation. And from laws of motion, what we can write? F equals to mass into acceleration.
Huh.
So we can write mu s into n equals to m into ACM. Correct.
Yes.
So n is how much? N is basically mg plus f.
F. Yeah.
So mu s into mg plus f equals to m ACM is how much? 2f by 3.
Yes.
And so you can rearrange. Minus. Is this the answer?
Yeah. It will be 10 then. Yes.
You got your mistake? Like what you did?
Yes. Yes. Yeah.
Where? Which line?
I think I must have messed up in that F part. Okay. Got it. I think I took it only as MR square by 2. That's why I was getting the
right.
answer 10 by 3, not 10.
Correct.
Yes, got it. I have here. Send.
Yes. Yes. The paragraph one.
Paragraph.
So you can just ignore the paragraph. You can just directly solve.
Because I read the paragraph, I was not understanding.
No, that is not required. We have done something like this. So for any rotating disk, if we have any object, just sorry, got a call. Okay. So the disk is rotating with some angular speed omega. Or is omega constant or variable? Is omega constant or variable?
Constant.
I will read the question. No?
Yes.
Just confirm me because I'm not reading it.
Constant. Yes. Yeah, it's constant. It's written in
Okay,
constant
fine.
angular velocity. Yeah.
So let's say if you are at a distance x from the axis, and if it is moving with the constant angular velocity, it will experience the centrifugal force. How much? M omega square x.
X. Yes.
Just you can read it. What they're asking. What they're asking the question is, what is the question?
Distance r of the block at time t.
Distance as a function. That's fine. So this force will give you the required radial acceleration, like acceleration along the axis.
Yes.
Along the groove, you can say. And because this is the acceleration which will determine x, so we just need this one. At the same time, we do have something called Coriolis force. And the Coriolis force is basically F Coriolis is written as minus 2m omega cross. So direction of omega, if I take upward, and if you take the v in the frame of the, so we take v in the radial direction. This is v radial because the block is moving along the radius. So if you write the v omega cross v, what is omega cross v?
But what is this exactly Coriolis Force doing here?
Because the actual path in the ground frame is very complex. No? In the ground frame, if you look at the top view, it's going like this.
Yes.
Let's say if you're going towards the edge, but in ground frame, are you going towards the edge or are you going something like this? Understood.
What's
If
the
you,
edge?
if you have a disc like this,
Huh.
as you go this way, the groove will turn here. No?
Yes.
So when you are actually here in the frame of the disc, you are actually here in the ground frame.
Correct.
So your actual path is something like this.
Yes.
Now this path is difficult to visualize. Okay.
Correct.
So omega vector is upward and VR is like this. So omega cross V will be into the plane like this.
Yes.
So minus omega cross V will be like this. And this force minus 2m is actually balanced by the normal reaction. Okay.
Okay.
Understood. So now the groove will provide some force, but we are not interested in the force which are acting normal to the groove, because that motion we are not interested. We just need a distance from the axis as a function of time t, right? So the
Yes.
only question that we should be bothered about is this question. So if you solve, you can write like this. So if centrifugal is m into radial in frame of disc along the groove, and this is m omega square x m. And how to write the radial direction? We can write as vx dvx by dt, right?
Yes. Uh,
Or simply
BX.
that's fine. We can write like this, or we can write as dvx by dt.
That.
But we'll add the x relation. Why? Because of the obvious reason. Here x is known, so we can add as vx dvx by dx. It is fine.
Yes.
And now you can rearrange that term. So omega square x dx is vx dvx. And now from where it has started? At the t0 x was how much? Can you guess? 0 or something else? The block initially was kept at what position?
R.
Have you read the question?
In the diagram.
No, not diagram. Read the question and tell me where the block was at t equals to 0. Was it released from the axis or away from the axis?
R is equal to R by 2 at T is equal to 0. It is at R by 2.
Exactly. That's why I
Yes.
was asking the question.
Yes.
So this is R by 2 to
Yes.
in general, let's say X.
Huh.
So this will give you how much answer? Omega square X square by 2
X square by 2.
from R by 2 to X. And V will be Vx square by 2. Well, initially 0. So omega square X square minus R square by 4 is Vx square, correct?
Yes.
So we got Vx equals to how much? Omega under root of X square minus R square by 4, right?
Yes. Yeah.
So Vx we can write as dx by dt.
Yeah.
So this is all about integration only. Okay. Now you can integrate this easily. So when t was 0, x was r by 2. Now this is the inverse sine inverse.
Yeah,
X.
sine inverse X square.
So how to write this? You can you can solve it. Put x equals to r by 2. Oh, this is x coming first, no? This is the difference. I need to write something else. Sec square. Correct?
Yeah.
So,
Correct. So it will be, yeah.
so it is different. So now if you write, you have to derive actually. So dx equals to r by 2 sec theta tan theta, right?
Yes.
So this is r by 2 sec theta tan theta d theta all upon r by 2
R by 2 tan.
6 square minus 1, which is 10, right?
Tan. Yeah.
R by 2 consists of 10 consists of. So what we are left with is sec theta,
Log of.
and which is ln of sec theta plus tan theta.
Plus tan theta.
Plus of course c. So this is the equation we are getting. Okay. Fine. So sec theta very simple way of doing it. So sec theta and tan theta from r by 2. Okay, what is r by 2? Yeah, I think if you put x equals to r by 2, theta will be 0 or sec theta will be 1, right? If we take the limit.
Yes.
So 0 to theta will be, okay, this will be eventually 0 to theta only, no? Yeah, that's fine. Okay, fine. So we got the answer here. Look at this carefully. If you convert the limit, if you put x equals to r by 2, theta will be 0.
Yes.
So it will go from 0 to theta. So I'm getting the answer directly. How much? ln, because we are putting the limit, so c will not come. Can we remove like this?
Yes.
Now here is the trick. So ln sec theta, and if I put 0, what I'll get? Ln tan 0 0 sec 0 is 1. ln 1 is also 0.
0.
So it's eventually 0. Okay. So I can just I should write actually, but anyway, if you can understand, I can just remove.
Understood.
And this is omega t, right?
Yes.
So sec theta plus tan theta is e power omega t.
Yes.
Now, if you know something advanced in trigo, the sec theta minus tan theta is inverse of the plus, right?
Yes, yes. That time.
You cannot manage this. And that's why if you add these two, you can solve for. So what is sec theta value eventually?
And sec theta.
Right? So we got
Yes.
sec theta equals to the sum by 2. So this is how we actually, this was the trickiest part that many should fail to understand. That's the only difficulty. Otherwise, you can solve. So basically, sec theta we can rewrite as e per omega t plus e per minus omega t by 2. And the tan theta will be just the difference. Okay. So what they're asking?
They have asked R in terms of T.
Yeah, so we got here answer. Na? So what is sec theta? X is r by 2 sec theta.
Yes.
So I don't need much. So r by 2 and sec theta is what? This one. We have already derived.
Yes.
So
R by
4. Do we have some answer like this in the option?
yes, option D. We have.
Very good.
Nice.
So it's a, of course, very interesting problem, I would say. And this was the trick part. That I think that is the reason it is difficult. Okay, so next. The net reaction on the disk on the block of the disk on the block. Ah. So 24 also. This is 34. 34
Yeah.
also you want?
No, I can solve it now.
Okay.
After the solution.
Yeah, you can just use the theory given in the paragraph. You will get the answer. Basically, you have to use the maybe the Coriolis Force to write the answer. Okay. And for Coriolis Force, you just remember the formula, that is good enough.
Okay.
Any other doubt or it's done?
Oh, one more sum I am having. My answer is not matching. I will see.
Yeah. Question number 50. Yes, tell me, guys. 50 number.
Yes, sir.
In 15, we have a plank. And over the plank, we have a sphere. It's a sphere, right?
Sphere.
And you give some initial omega, right? You give some spin to the.
Yes.
And it is gently placed on the plank. And there is a coefficient of friction mu. And the plank is resting on the smooth frictionless surface, right?
Yes.
So in the very beginning, friction will act will be kinetic friction because it will have the relative motion. So the kinetic friction on the sphere will be forward
Yes.
and the plank will be backward.
Backward.
And there is no other force. Okay. So now you can solve for the laws of motion for both the plank and the. So for plank, the acceleration is simply Fk by m. Done. What is the mass of the sphere? Same or different?
Same. Same.
So you can add the acceleration of the sphere will be also Fk by m only, no? Because the only horizontal force acting is Fk, so this will be again Fk by m.
Yes.
So what is the relative acceleration? 2a.
Yeah.
That's simple.
Oh, okay.
So what was your mistake?
No, I didn't take that relative part, so I was getting some other option.
Check the answer.
Uh, yes, it's correct. Okay.
Oh, fine. Okay, so now we can go back to the electrostatics, right?
Yes.
So today we are going to start the electric field to continuous charge distribution. And what we saw in the last lecture that so we saw that the electric field formula that we are aware of in scalar form that we write as E equals to KQ by R squared is only true for the point like charges. Okay. So the question was, what if we do not have a point charge? So we have to use the, of course, elementary. So by taking a small piece of charge, you can create an elementary, and once you have the elementary, you can use the formula, and then you can integrate or do something to get the answer. But there was a catch. You cannot just integrate the way you want. Electric field is a vector quantity, so the actual way of writing is AQ by R cube into R vector. So until all elementary do not have the same R, we cannot integrate because integration is only meant for numbers. Okay, so we can only do the integration for numbers. We cannot do the integration for every other thing. So in the vectors, you can only do the integration either if they have the same direction, or if they don't have the same direction, then we can do the component thing. You can take the component in one particular direction and we can add those components together. So what we generally do is we resolve along two mutually perpendicular direction, which is convenient to us, and we integrate in each direction separately, and then we again join them together using vector notation. So what you need to be very careful is that field is a vector, and unless the direction is not matching, one should not use the. So unless the direction is not matching, you cannot integrate. So what you need to think is how we can resolve and integrate. So that's the whole idea. So the d vector you can as k cube by r cube into okay dq by r cube into r vector. So generally we write r vector in terms of I cap and j cap. That's a way of writing. Okay.
Yes.
So we did the equation of electric field along the axis of the rod itself. Like the point at which we were trying to find the field was along the axis, and this was the most trivial case. Why? Because no matter where you cut the elementary, every elementary will contribute towards same direction. Correct? And this was the luckiest case. Like when you think of elementary, and if every elementary contribute in the same direction, then we are not bothered about the vector notation per se. So although it's a vector, but the direction is matching, it is as good as scalar. So you can just add the value and you can get the answer. Okay. It is clear.
Yes.
So now what if we have a situation which is not similar to the previous one? So now we have a rod, and in this case, what is given to us? So lambda is the linear charge density. So that is a convenient way of writing. And whenever lambda is there, you can add dq equals to lambda into some length. That's called dA. Okay. Now, are we looking for the electric field on the axis or off the axis? The answer was, of course, off the axis. So I'm looking for somewhere here, the point P. Now, if this is the point P, then the end of the rod will subtend some angle at the point P. Be very careful about where the point P is and how the variables are assumed here. So this is called D. D is the perpendicular separation between the point and the rod. Okay.
Yes.
So D is the perpendicular separation between point and the rod. That's a given to you. So this is a variable which is known to you in advance. Lambda is given. What else they will give you? The angle that the end will subtend at point P. So if the perpendicular which I have drawn from P to the rod is like a reference line, and the two ends are on the two sides of this reference line. Let's call one angle is alpha, another is beta. So alpha and beta are the two angles. So these are the like parameters which is known to you in advance, and now you're supposed to find the electric field at point P. A small analysis will let you know that every element will not contribute in the same direction. So that's the first and foremost thing we need to be careful about. So given a point P, you just choose a random location. Just choose any random location. So if I choose a rod, a small piece of rod here, the way it will contribute is this, correct?
Yes.
So the electric field, because this is like a point charge, you're taking a small point charge. Of value dq, and we always move some distance from the reference. So let's say you have moved y and you have cut dy. Okay. And because it's a very small piece dy, so the dq will be how much in this case? What will be dq here? The dq must be lambda multiplied by,
Lambda dy.
correct, because on a unit length we have lambda charge, so in the length of dy the charge is lambda dy. Now just try to forget about the rod, think about the point charge and think about how the point charge will be able to create the electric field at the point P. So we know it's a positive charge, it will create a field away from itself like this, right? So the electric field at the point P that will come from this contribution from this charge will be like this. And it will have one unique direction. As you can see, this is the direction of the field. So the contribution of this is d like this in a direction. Now, can you tell me that as you move away from the reference, upper, upside, or downside, the direction of electric field due to every element will be same or different? So every element is going to contribute in the same direction or in different direction? That's a simple question to you guys.
Different.
So different.
It's a definitely different. I mean, it's not that you should be confused about. Take anything here and draw the line. You will realize yourself. Okay, this is happening. And if you go bottom, then it will contribute in the upper direction. Imagine a scenario when we have equal length up and below. Like if the perpendicular which you have drawn is exactly bisecting the rod. If alpha and beta are equal, in that case, for every elementary above, there is a symmetrical elementary below. And when we have two elementary which are symmetrical, in that case, the component will only add up in the perpendicular direction, and this component will cancel out. Do you realize this? So if we have symmetricity, can we say only the perpendicular component will exist and
Yes.
the other one will cancel out?
Yeah.
But here right now that is not the case. So we have unequal values. We have alpha and beta here. And now again the issue is same. We cannot integrate vectors. We can only integrate numbers. Numbers are scalars. So integration is only meant for the scalars. Or if you have vector, you have to convert into component, and we can do the integration of components separate. Okay. So to make this integration possible, I will first choose some angle theta. And we know that every component or every electric field at the point P will have only two components. One, let's call it perpendicular to the rod. I'll call it dE perp. And other we can take as dE parallel. So there are many ways of writing it. You can write the way you want. And why this is required? Because every elementary will contribute in a different direction. So by resolving, we can make sure that we can at least integrate each component separate. Okay. So what is dE perpendicular? Okay,
E
before
cos theta.
yeah. So before we find this value, let's find what is dE itself. What is dE? So dE is the electric field due to a point charge. So
K
what is
dq upon
K?
dq upon
And let's say
the
this is D.
distance.
Yeah. So what is the distance? What is the distance of the point charge from the point P? You can see it. No?
D sec theta.
Yeah, that's correct. So let's call it R. In terms of R, we can write as R cos theta is D. So R is D sec theta.
Yes.
So as of now, let's write down R square. Okay, and we will be substituting, of course, R. So let's simplify the DE first, and then we'll proceed to the derivation. So the DE value, which turns out to be K dq by R square. And as we have discussed, the dq we can write as lambda into dy. And we want our answer, of course, in terms of theta as a generic variable. So it's good to write this as d sec theta. Again, you can see there is a lot of variable. Theta is a variable, but y is another variable. The integration is only possible when we have single variable.
Y also in terms of theta.
Yeah, so it's a good idea to write y in terms of theta. And to do that, what we'll use? So you
D
can use
tan
this
theta.
triangle. Very good. So tan theta is how much? Y by d. So y turns out to be d tan theta. So now what is the dy by d theta, guys?
D sec square theta.
Excellent. So the dy turns out to be d sec square theta into d theta. So having done this, you can go further and simply substitute the values. Dy was d sec square theta into d theta whole upon d square sec square theta, and what you can see, the entire term gets cancelled. So we have a really simple answer for d, which is k lambda upon d into d theta. Now again, before we proceed, we'll try to do some analysis of the answer or the result that we have obtained. So if you look at the answer, it says something very interesting, that it has nothing to do with the distance, because this entire term is constant, right? So the
Yes.
electric field is like a proportional to the angle subtended by the elementary at the point P. Do you realize this?
Yeah.
What is happening? The answer is only proportional to the angle subtended by the elementary at the point P, because actually I should have drawn like this rod, and let's do a perpendicular. The way you have cut the elementary is like this. Theta is here, and of course this is d theta. This is your dy, right? This is theta, and this is your d theta. This was the actual answer. Now, as theta will change, let's say if you go, imagine two lines we are drawing further at the same angle, d theta. What will happen? The new dy is going to be bigger than before, isn't it?
Yes.
What we can realize that although the d theta is same, but dy dash will increase, isn't it? So the more you tilt towards the tilt away from the axis, the same angle demands bigger size of the rod, isn't it? So there are two things. As you go away, if the angle is same, then charge will be more and more and more, isn't it? Are you getting this idea? What I'm trying to say?
Yes.
So what we can see that as R will increase, the charge will also increase. And that is the reason that the ratio turns out to be constant. So the angle subtended really matters. And as you go away from the reference line, which I always take by this one, the elementary subtending the same angle are not equal in length. They are different in length. Do you realize this?
Yes.
Okay, so that is the first meaning of why this answer is coming the way it is coming. Okay, so that intuition should be in your brain that okay, as we go away, as r will grow, the dy in a way will also grow. Okay, so you will get bigger and bigger dy's for the same d theta. So d theta is actually important, not the dy. Okay, so anyway, this was just a small discussion which will have implication later on. Now coming back to the derivation, once you get the d, what we are trying to find is d vector, not d. And d vector we can write as d perpendicular. Let's draw x and y axis. So if I choose this direction as x axis because that's convenient to me, and this as y axis, I can choose down also, doesn't matter. Then the d can be written as d cos theta I cap and d sin theta minus j cap. Do you realize this?
Yes.
So for the given diagram, the d vector we can rewrite like this. Now it is up to you to either integrate d separately or so the e vector, e is a vector, is basically integration of d vector. We don't write e is the integration of d. That's wrong. So you should not, once you get d, don't do this that e is integration of d. This is wrong. Why? E is a vector quantity. You cannot just integrate to expect to get the net answer. This is wrong, but this is right. Okay. So E is actually equals to d vector integration, which in turn will be d perpendicular integration I cap and d parallel integration into minus j cap. And that is why I said you can do these integrations separately. So integrating d now converted into integrating the component and adding them together. So it's up to you to choose separate value. So let me just find E perpendicular eventually. So what is E perpendicular? It's the integration of D perpendicular, and this can be done. Why? Because this is representing one dimension, not two dimension or not three dimension. So E perpendicular means everything in the direction of perpendicular. And what is that? If you look carefully, it is D cos theta, right?
Cos theta.
And it's pretty simple because you know what is DE. Then integration of this kind is the simplest of integration. Now what about the limit? Now theta must vary to cover the entire rod, and you can see the reference line is the perpendicular and theta is on both sides of the line, which means you need to turn clockwise also and you need to turn anti-clockwise also in order to
Alpha and
capture
minus
the
beta.
in order to capture the entire rod. So definitely the angle must be taken from minus beta to plus alpha. And I hope this is the integration which you understand easily. Cos theta d theta,
Sin
what is
theta.
integration? Sin theta. And it is minus beta to plus alpha. So this turns out to be sin alpha minus sin of minus beta. Okay. So this is the answer. And now if you want, you can simplify by taking sin of minus theta is sin of
Sin
minus theta
alpha
is,
plus sin.
yeah. So this turns out to be the very famous answer which we all are aware of. So we got only one component which is sin alpha plus sin beta. Now there is a particular case in which you may get confused. So if the rod is like this and the point P is here, you can see I cannot draw the perpendicular from the point to the rod. I need to extend the line first of all. So what I'll do is I'll extend the line and then I will drop a perpendicular. That's the rule. So now I got my reference back. but the distribution of charge is only begins from here. So the rod begins from the reference, I mean above the reference, and ends on the same side. So in this case, if you try to relate the angle, the bottom of the rod or the beginning of the rod will separate some angle like this, and the top will separate something from here. So as a rule, as I said, what I said, the angle must be taken from the reference, and if the reference is not present, extend the line and draw the reference. So let's say this is the alpha, the big angle, the small angle is beta. Then clearly the E perpendicular will change here. Why? Because the integration limit will change. From where to where? It begins at beta and ends at alpha. So beta is the beginning. So from reference, if you turn, see, always remember, you need to start from the reference, and from the reference, if you turn at beta angle, you will get the first end of the rod, right? And once you turn by alpha, you will get the end of the rod. Understood? And therefore, the E perpendicular formula will change slightly, and it will become sine alpha minus sine beta. So this is the generic formula, because if you substitute beta equals to minus beta, you will get the answer. Understood? So the E perpendicular, the way one should remember is this. Okay, so let's do the E parallel now. So what is E parallel? The numerical value is d sin theta. Integration,
Which
right?
sum we are doing?
Pardon?
This one. E parallel of this.
Yeah, E parallel here.
Okay, okay. Yeah.
So, and in case of E parallel, there are no two cases. We have only one case, because cos of minus theta is cos theta only, right?
Yeah.
So this we can write as d sin theta, and d is k lambda by d into d theta. Always remember the derivation, because it's not difficult. You can just remember the answer. K lambda by d into d theta. Okay.
Yes.
Now we are done.
Cos beta minus cos alpha.
So of course it will be, first of all, the sign integration is minus cos theta and minus beta to plus alpha, which is as good as so cos is a decreasing function. So for a small angle, it will have bigger value. If beta is small, then beta is bigger value. Cos beta is bigger value. Correct. So we always subtract the cos of small angle minus cos of big angle. That's the way to remember. Don't think about the diagram and all. Just because you're writing the value what you like, cos of big angle minus cos of small angle. Is this clear?
Yes.
So this is the perpendicular component, and sorry, parallel component, and we have the perpendicular component. So net E will be how much? E perpendicular I cap plus E parallel minus J cap, as we wrote earlier. So what is the modulus of E? What is the net value of electric field? You just need to square and add, and then you can get the net value. So EP we can write as, so I can take the common as k lambda by d in both cases, and what we're left with. So if you simplify this, you'll get something really interesting answer. Can you simplify this?
Yes.
Do this.
Hello.
Yes.
2k lambda by d
Mhm.
sine alpha plus beta by 2.
Excellent. So the EP turns out to be 2k lambda by d into sine of alpha plus beta by 2. Now this is something interesting. So what is interesting here? If you look carefully, the alpha plus beta is the total angle subtended at the point P, right? If we have a
Yes.
point P here, and if I simply join the ends to the point P, then the net angle which the rod is subtending is actually alpha plus beta. Okay. The net angle it is subtending is alpha plus beta, and by 2 means half of this angle.
Angle bisector.
Angle bisector. The most interesting thing about this uh, answer is that the direction of a resultant electric field is also in the direction of angle bisector. That's very fascinating. That the net electric field will be exactly the bisector of this angle. You can see the angle bisector. You can section this line. Of course, it's not going to be the bisector of the rod, but it is the bisector of the angle only. And this is the actually direction of net field that we can prove easily, but that's not very difficult. So whenever we have a rod, and if you have a point P, the direction of net field we can directly write like this. And direction is bound to be the angle bisector, no matter what. So let's take some example, which is, I mean, easy to understand. If you have a rod like this, and if I choose a point P exactly, and this is lambda, the total angle subtended is this much only, you can see. So let's say the total angle subtended by the rod is theta, isn't it? So the net electric field at the point P is bound to be this one, the bisector, no matter what. So the net electric field is always the bisector, theta by 2 and theta by 2. It is clear?
Yes.
And what is the most interesting fact that you should be aware of? That if the rod is, let's say, semi-infinite, like you cannot see the other end, and if the point P is exactly here, then this angle will be how much? So if you join something to the infinity, this is theta theta. As you keep on moving infinity, this angle will keep on increasing.
Yes.
So at real infinity, it will look like this.
9.
Almost 90.
Yeah.
Can you see this is tending to 90? So for what you need to remember is that from the reference line, because this is by default a reference line because it is perpendicular. If the end of the rod is at infinity, the angle is 90. So we say that the angle subtended is 90. On the other side, we don't have any rod. So the net electric field at the point P will be again angle bisect. Do you realize this?
Yeah.
But this time it will be exactly 45 and 45. Understand? And you can get the answer directly. What is the EP value here? 2k lambda by d sine of angle subtended by half. What is here? 2k lambda by okay, di. Okay, you can show it. Into sine of angle subtended by 2. What is EP here?
Root 2.
2k lambda by d into sine of 90 by 2, which is 1 by root 2 or sine 45. So given the entire rod or any line charge, the resultant field we can find directly, which is very convenient and easy to find. But still, I will emphasize that you should remember the component, not the net field. I mean, of course, net field you can derive. So it's a good practice to remember the component, and then from there you tend to derive. So this particular case is of my great interest because this resultant is at 45 degree. Can we say both the components must be equal?
Yes.
So this is a special case in which the components becomes equal and not just equal. It's very easy to remember. It's only k lambda by d.
K lambda.
And that's why the semi-infinite case is very, very interesting and important to us. Okay. So the moment we have semi-infinite, exact semi-infinite, with this situation that the point P lies at the edge of the rod, the answer is k lambda by d in both directions. And therefore, this is something which you need to remember. So I hope this is clear.
Yes.
So we'll take the two separate infinite case. So if we have a rod which is infinite in one direction, other is finite, or the other we can see, but the point P is not at the edge. The point P is somewhere here. Now, the angle that the finite end will create, you just need to add 90 to that, because of what I said, for everything infinity, the angle is 90. So what is the total angle subtended at the point P? 90 plus theta. Understood? Do you realize what I'm saying?
Yes.
So whenever we have a situation like this, if one side is infinity, other is finite, we only take the finite angle separately. So the total angle subtended is how much?
90 plus 3.
And therefore the net electric field will be, and this is the net angle. You have to take the bisector of this angle. So maybe something like this. Okay. So of course it will be something like this. And this value will be how much then?
2k lambda by d sine 90 plus theta.
So 2k lambda by d sine 90 plus theta by 2.
Yes.
Okay. That's a very weird answer, but let it be. Or if you want to find the component separately, what is E perpendicular? K lambda by d sine 90 plus sine theta, right? What is E parallel? Cos 90 is 0, so we can just add cos theta. Only one value. We always take the cos small angle minus cos big angle, if you remember. Cos of small angle is bigger, right?
Huh.
So the parallel component, how we write? Cos of small angle minus cos of big angle.
We take cos of big minus small.
Always take the cos of
No,
small minus big, because
okay.
small angle will have bigger cos, right?
Yes.
And we are just writing or representing the value. So this will look like k lambda by d 1 plus sin theta. And this is k lambda by d cos theta. So if you want, you can square and add, you will get the answer as same as above, or you can leave the way you want. And the third case which I am particularly interested is the other end is of course at infinity, but the point P is here. In this case, first I need to extend the line, and then I will complete my reference. And once the reference is completed, I will join this P to this end. Now only the one end will take, because other end we know is 90, right? So what is the angle subtended here? Can you guess?
90
Anybody?
minus theta.
Right. So the net field we can add directly 2k lambda by d. Again, we should do sine of 90 minus theta by whole 2. So of course these things are not always very simple to realize. It's difficult only. But anyway, so this is the answer. 2k lambda by d sine 90 minus theta by 2. This is the net field. If you want the component, you know how to do it. So what will be the E parallel perpendicular one? Because the rod is on the same side of the reference, the formula is k lambda by d. Sine we take big angle minus small angle, but here it is sine 90 minus sine theta. And what is E parallel? Is small angle minus big angle. It is 90. So anyway, what you get here is k lambda by d 1 minus sin theta. And what is E parallel? K lambda by d cos theta. That's it. Is this clear, guys?
Clear. Yes.
So the one more case which is of our particular interest, which you should in fact remember the answer. So what if the rod is infinite on both sides? So it means you cannot see the beginning, you cannot see the end. Okay, sorry. So if what if we have the infinite rod from both sides? The infinity is both sides, so you cannot see the beginning nor you can see the end. First of all, you need to realize that if something is really infinite, technically or logically, then no matter which point I choose, the length of the rod above this point will be same as length below because it is infinite, right?
Yes.
So first of all, this you need to realize that every point which you can take will have equal length up above and below. Okay. So the length of the rod, so it is like every point is a point of symmetry. So if every point is a point of symmetry, then how to deal with the point of symmetry? If you remember, if a point is a point of symmetry, then the only component will exist is the perpendicular, right? Because the symmetricity of above and below will cancel the which component? The parallel.
Vertical.
But to understand this, you can think like, let's take the lower half. The lower half will create an electric field like this, right and up. But the upper half will create a below and right. Do you realize this?
Yeah. So it will get fast.
So it is like a, the net answer will be twice of the E perpendicular due to the semi-infinite value, right? So if
Yes.
you can break this into two semi-infinite wires, and then you can find the field of each wire separately, and then you can see clearly that the parallel will get cancelled and the perpendicular will get added together. So the net value will be either you can say 2E perpendicular, or this turns out to be 2k lambda by d. Okay, that's the right answer. Or if you want to solve by the formula, 2k lambda by d sine of angle subtended, which is 180
180.
by 2. So again, it's the same answer. Now, this arrow method is important because you should be aware of what is happening, which component is getting cancelled, why it is getting cancelled. The direction more than the answer should be visible to you. If you're not able to see the direction, it means there is something wrong. I mean, you cannot just solve mechanically. You should have the intuition that what exactly is the direction of the field lines and why some component is getting cancelled. Okay. So for semi-infinite, I expect that everyone should remember the answer 2k lambda by d. And now time has come for solving some tricky problem, which I'm going to give you. So let's say we have a coordinate axis. So you can see there is the beginning, there is a no end. So beginning is, you can see, can you see the end? No, that's infinite. So the question is find the electric field at point O. So find the net electric field at O. So you can take 5 minutes to solve, then we'll come back. Yes, tell me.
So I'm getting 2k lambda sine theta by 2. Distance I'm getting
How much?
not sure.
First of all, you need to draw the perpendicular from the point of interest to the
A
reference line.
sine theta.
Yeah, correct. Ah, sorry, this is my mistake. This is theta given. My
Theta,
mistake.
no?
I simply missed it. I don't know. So what you can do is you can extend the line and then draw a perpendicular. Okay. Rishi, are you solving?
Yes, sir.
You should tell me some answer. Na? At least tell one answer.
Yes.
So apply the concept that we have learned so far and try to get this answer. Take your time, realize what is happening, what you are missing, what is the D representing, because the D is very crucial. So here you can see what is D here? The perpendicular from the point to the line. Understood? So this is your D, which you need to of course calculate because it's not given to you. That's the first challenge. Find the D, and the second is realize what is given, what is not given, and so on. So, what is the angle subtended by the way in this case?
Theta by
What is the angle subtended at O? Hmm? What is the angle
theta
subtended?
only.
Yeah, it's theta only. Correct. The angle subtended is theta only. If you have realized this, then your answer is done. You got the answer.
Oh, I told 2k lambda by A sine theta by B.
So the EO turns out to be 2k lambda sine theta by 2. This you can write as A into 2 sine theta by 2 into cos theta by 2.
So A cos theta by B.
Yeah. So this is k lambda by A sec theta by 2. That's the answer. It is clear, guys?
Yes.
Now these questions are particularly questions of infinite and semi-infinite are very popular. So let's do some question of infinite and semi-infinite. So let's say we have a wire which is running parallel to the x-axis and then parallel to the y-axis, and it is infinitely long in both directions. And the lambda is here. This is lambda. And on the z-axis, so you choose a point P here, and you can call a distance as 0, 0, A. Find E E in vector form. You can write the answer in terms of I cap, J cap, and K cap, whatever. Okay. So try this question, then I will solve it on. So it's a three-dimensional problem, and you need to deal with two separate plane actually, because the point P and the bottom bar is in XZ plane, but the same point P in the and the vertical wire is in the YZ plane, right? So definitely we get two answers. And every answer should be written in terms of I and J. So here I will suggest you to use the component method than the net value. Use component. I'm suggesting.
Hello.
What is the answer?
So I have a question. How can we take the distance here then?
Distance is given na A.
Achha, that is A. Thought that's
0, 0 or
Okay.
A. No? The point P is
Okay.
0, 0 A.
Okay,
Right?
okay, okay.
So this means the length from here to here, this is A. No?
A. I thought that is 0.
How it could be 0? Come on.
Yeah.
Anybody getting the answer? Or shall I give the solution?
1. Hello.
Yes.
2K lambda by A.
Tell me the answer in terms of I cap and J cap.
So 2K lambda by A I cap.
I'll just tell you what is the answer. The K lambda by A is going to be common everywhere, right?
Huh.
Now for the X axis, the plane is X and Z. Okay, so the field will be this and this, right? The electric field will be in the same plane, perpendicular and parallel.
Yes.
Whereas for the Y axis, it is going to be down and away. So what you can realize, the X component is minus I cap,
And minus
minus
J.
J, and plus 2K. That's in one line sorted. Do you realize this?
Understood.
We need to check for the plane, and once we are done with the plane, we know the component will be in that plane, one parallel and another perpendicular, and that is why it was given the in same infinite. So now if you want to find the magnitude, you can now you can find the answer. So K lambda by under root of 1 plus 1 plus 4. Okay. So root 6 K lambda by. So now what if we have two so we have two wires, and now these are infinitely long wires. And this angle is theta. Okay. This question, no, this question I don't know. Like this. Okay, now the same wire is now bent at angle theta. Earlier it was 90, now it is theta. Okay. And where I'm looking for the electric field? Now I'm looking for the electric field at a distance r from the bend at angle bisected theta. I want answer here. P. Yes. to find the value of P. I think this will be challenging. You can try for a while, then I will check. I don't know
Yes, sir.
how easy or difficult it is. Let me help you. So,
So what I did, I first drawn the perpendicular from P
so for the
to the
bottom
north.
bar, this is the like this is the one end, right?
Yes.
Okay, because this is the perpendicular. So,
Yeah.
and this is like 90 minus theta by 2, right?
Yes.
Let's keep it alpha as of now. We'll do it later on. So what do we know that the resultant is going to be bisector of this line, correct?
Yeah.
And for the other wire, this will be the like other end, like parallel to that wire. Understood? And this is the angle, which is again I think 90 plus alpha, right? So if both are 90 plus alpha, then how much is this actually? This is pi minus 2 alpha, correct? Because the sum is 2 pi.
Yes.
So basically, we at point P, we have, yeah, I think it's very difficult. So we have basically something like this. Um, seems to be really difficult. So the one is the bisector here, and other is the bisector here. Bisector. So this will be how much? If it is bisector, this will be, or this will be how much? 90 plus alpha by 2. This is also going to
Yeah.
be 90 plus alpha by 2. Okay, now if this is E, this is also E. Let's say E is the net value for each wire separately. So we can say the net value in this case will be 2E cos 90 plus alpha by 2. And what is E actually? E is due to one wire. And due to one wire, we know the answer 2k lambda by D, which is R sin theta by 2, into sine of angle subtended by. Okay. So given this E, the EP turns out to be 2k 2 into E, which is 2k lambda by R sin theta by 2 into sin 90 plus alpha by 2 into cos 90 plus alpha by 2. Correct? Now this is the entire thing. So this turns out to be 2k lambda upon R sin theta by 2. And 2 sin into cos will be how much? Sin 2 theta.
Sine 90.
And sin 90 plus alpha is what? Cos alpha.
Cos.
And alpha is how much? 90 minus theta by 2. Alpha is 90 minus theta by 2. So cos alpha will be sin theta by 2. Oh, eventually this is sin theta by 2. Oh my god, this answer is amazing. 2k lambda by R. So maybe, I mean, you just need to check for calculation, because even I will not guarantee. I have done this in hurry. So difficult. I think this is difficult. Leave it. The next concept that we need to be careful about is called application of this particularly infinite one. So let's say you know the answer for the infinite, right? One second. So if you have the infinite line charge, lambda is the linear charge density. What is the electric field at any distance r from the wire? The electric field at any distance r will be how much? 2k lambda by
D.
So 2k lambda by r,
R.
correct? Now this formula is something that I expect you to remember actually. Okay.
Yes.
So therefore, let's see some application. So we have a infinite sheet of finite width. So it is infinite lengthwise, but not widthwise. So the finite width is given as B. Now because it's a sheet, so it will have the surface charge density. Sigma. So sigma is the surface charge density. What we are supposed to find? We are supposed to find the electric field at point P. Okay. So of course, we do not know the answer for the sheet, but we know for the thin wire. And what we understand that a sheet can be assumed as a collection of thin wires, isn't it?
Yeah.
So you can definitely cut something like this, a thin wire. You can cut as thin as possible, but let me make it bigger to just to realize. And this thin wire will actually act as an infinite line charge. Do you realize this? So from point P, I choose a random line charge at a distance x, and the thickness of this is dx because this is how we cut. But lambda is not given, rather sigma is given. So how we can correlate the lambda with sigma?
Sigma is dq by d.
How much?
dq by d.
So sigma and lambda relation. We have to think in sigma and
Oh,
lambda.
lambda. Oh,
Because we are looking for lambda, but what is given is sigma, right? So to find the sigma and lambda relation for anything, you can say the thickness is dx, length you can take as any value, let's call it L. Now the charge we can express in multiple ways. In terms of lambda, charge will be lambda into A, the simple definition.
yes.
But in terms of sigma, lambda will be charge will be sigma into area, which is L dx. So we have charge and we
Lambda
have
will be sigma dx.
so sigma and lambda are the two separate representation of the charge distribution. But to express, you can choose any one of them. And therefore, what you need to realize that lambda is basically sigma into the width of the line charge. So that is how the lambda and sigma will be related. And why this is important, because we know the formula due to lambda. So you can say dE at the point P will be how much? What is dE value? 2k lambda by x, correct? Because
Yes.
the line charge is x away. But lambda is not going to be as sigma dx. And now you can clearly see all such lines will contribute in the same direction. That's why the angle is not the issue. So because every line which you cut will contribute in the same direction towards the right. So the net field at the point P will be integration of d, correct?
Yeah.
And this integration will give you how much? 2k
Log.
dx by x from, okay, now x will vary from where to where to cover the entire sheet. So what is the limit of integration? Chris, tell me what is the limit of integration?
Smile. Sir, eh, um, uh, b minus b minus a to no, b minus a to no. B minus a to a.
Do you understand the meaning of limit of integration? What is the meaning of limit? Like why we talk about the limit?
Oh, we have to cover the full.
So and how from where you started the measurement of x? What x is representing?
Distance from P point.
Of what? Distance of what?
Distance from dx.
Distance of what?
Distance of the sheet.
Distance of what? What the x is representing?
A part of a charge.
It is representing the elementary you have taken from the point P. How far the elementary is located from the point P. So how far the elementary is located? X distance away. From
Okay.
where? Point P.
Fine.
Do you realize this?
Yeah.
Okay, so as you start your journey from P, when the first edge of the sheet will appear after traveling how much? How
A.
much you must walk to reach the first edge from point P?
A.
A. And to reach the extreme edge, the other edge, how much you have to walk from point P?
A plus B.
Exactly, that's called the limit.
Okay.
So the limit is
I
A to
couldn't
A plus B.
imagine that
X is
diagram.
always the distance you have to travel to cover the sheet, and because X is taken from the point P, so you have to walk from point P and then think about it. Okay,
Yeah.
so EP turns out to be 2k lambda 2k sigma ln A plus B by. Is this clear, guys?
Yes.
So now we saw the question in which we have a sheet and the point P luckily lies in the plane of the sheet. But what if the point P is not on the plane? What if things are different? So there is a very special case. Let's say a sheet is bent into a semi-cylinder. So basically the sheet is going into the plane, and what I have drawn is called the cross-sectional view. Something like this. So the sheet is bent in a shape of circle, a semicircular cylinder, you can say this as semicircular cylinder. Draw this first. Okay, anyway. I hope you understood the shape, right? Okay, all of bad designs. And so that's the idea. What we have is a semi-circular cylinder, and so we are supposed to find the electric field at the center of the axis, basically center of the axis. You can think this as the axis, the central axis running from here to here. And we're trying to find the electric field here. Oh, and this is the lambda. Sorry, this is the sigma again. Now, if you cut an elementary here, if you cut an elementary, it will look like a again infinite line chart. Okay. So how the elementary will look like? So because it's a circular, I'm showing you the two-dimensional view. So we'll move from the line of symmetry by theta, and then we cut a small d theta. Okay. So what this d theta is representing? So this element is the d theta part. This you can say dl length. Okay. So this dl will act as a width, right? So lambda in this case, the way of writing will be sigma dl. Do you realize this first? This is the most important part. Understanding the lambda.
Yes, sir.
So here we had x to dx. So dx was the width. Now here we move like this. So dl is the width. So given the radius r, I can further rewrite as r d theta. And what else we can say that this will create the electric field this way for sure. So any infinite wire will create the field in the radial direction, correct? So this will be the dE. Do you realize this also?
Yes.
Now, because of symmetricity, we know that the horizontal component will cancel out and only vertical will remain, correct?
Yes.
So the only dEy will be the part which will eventually exist. Because for every element on the right, there is a symmetrical element on the left also, which will create the field like this, and this, therefore the vertical will add up and horizontal will cancel. But I'm not taking two elements. I just want to keep the single element integration. So what is the value of D now? So D here is representing the electric field due to infinite line charge, correct? Here D is not due to point charge. It is not a point charge, it's an infinite line charge. Do you realize this? Maybe.
Yes.
So this D we can write as a formula. What you can write? 2k lambda by r. That's simple. So the D turns out to be how much? 2k by r, and lambda is sigma r d theta. This is the d value, but what we want is dy. So I will multiply with cos theta. Is this clear? So dey turns out to be how much? 2k sigma r gets cancelled, and then we have cos theta and then we integrate from where to where. Now the integration will go from minus pi by 2 to pi by 2. Correct? Minus pi by 2 to pi by 2. So this will give you the answer how much? 2. So the EY turns out to be how much? 4k sigma. Because cos will give you the sin theta, sin 90 minus sin 9 minus 90, which is
Yeah.
2. And k is 1 by 4 pi epsilon naught. So it's a very famous and interesting answer, sigma upon pi epsilon. So this is the electric field due to the semicircular cylindrical sheet. So electric field due to infinitely long semicircular cylindrical sheet. All right, so not very difficult.
Yes.
Okay. We can generalize this answer. What do you mean by generalize? So we integrated it for the what limit?
Minus pi by 2 to pi by 3.
So what if I don't want to do that? If I write, if I want to integrate from minus alpha by 2 to plus alpha by, let's say the arc is subtending. The sheet is not there. It's just a piece of circular arc. So instead of taking the half, what if I take a small portion? Something like this. And this entire angle is alpha. It is alpha by 2 on both sides, right? The field will be still in the y direction. That's totally okay. And this y will be how much? This answer. So this turns out to be 4k sigma sine alpha by 2. Okay. Am I right? Not 4. Yeah.
Will
2
not
sine
be.
alpha. Yeah, correct. 2 sine alpha.
Acha, that. Okay.
So the answer is 2 sine. So this will be still sigma by pi epsilon naught into sine alpha by. So if you put alpha equals to 180, it will become the answer which you got. Correct.
Yes.
So I hope this is not very difficult to understand.
No.
Don't try to remember all of this. Try to learn the derivation. That's my only suggestion. Even at this point, if you're not learning the derivation, so you're doing injustice to your learning and probably wasting your brain ability. So don't try to mug up everything. Learn the derivation and you will be at ease. Okay. So the next part is called, okay, you can do one more challenging problem. Infinitely long so infinitely long sheet with finite width. Okay. And what I'm showing is the cross-sectional view. So every time I'm not going to draw like this. So whatever you're looking right now is the cross-sectional view of the sheet. So how is the sheet? On both sides, right? Sheet is into the plane. Sheet is into the plane. Okay. So the sheet is into the plane. What I'm trying to ask, a different question for sure. So let's say we have a point P on the line of symmetry. I can make it asymmetric as well, but let's keep it simple for the sake of solving. So let's say h is the height. Okay. So can you find the net electric field at point P? Find. I think L is not required now. If you want to express an answer in terms of theta, L will not be required. But anyway, so you can ignore the theta, take L and H as your answer. Find EP in terms of H and L, or okay, or in terms of H and theta. You can choose whatever you want to express. So please try for a while and then I'll solve this again. Everyone go ahead. These are challenging J advanced level problem. The minimum you can expect in J advanced. And for that you need to do the integration. Krish, how much comfortable you are with integration? Not at all, somewhat, or very good. Like when I say take elementary, do you get scared? Like this is not something I would like to take. Or you feel comfortable? Okay, no, I love elementary. I know how to take elementary and do the integration or differentiation or whatever. Am I audible, guys?
Yes.
This is not there. Rishabh, you are there?
Yes, sir.
So tell me something like, do you feel comfortable with the integration part?
Yes, sir. But yeah, little less.
So you can, you all can watch my very, I mean, I have put a separate video a long time back in which I have only taught the elementary actually. That is called the mathematical tools. Okay. In the mathematical tools, there is a topic called integration. So you maybe you can search there, and you will see there's a separate discussion only on how to cut elementary in physics or in mathematics, and what is the purpose of cutting the element. So go back and watch if possible. It will take just 2 to 3 hours, in which I have covered almost everything. I'll share the particular link and will mention the time stamp also, so that anyone who feels not so comfortable with the integration or why should we take it, you can watch and get yourself comfortable.
Okay, sir.
I'll share today. I'll just check because it will take some time for me also. See, once you actually understand the integration, the rest is only application. So this chapter will not look difficult to you because you know integration, you know how to take elementary, and every time you get some integration thing, derivation thing, at least repeat 2 3 times till you get comfortable. Don't just leave as a formula. That's my request and suggestion. Anyway, please go ahead and try your bit. Don't worry if you don't get the answer. That's totally okay. I do not expect answer. I expect some effort from all of you. That's it.
Hello.
Yes.
Is the answer 2k lambda h upon hello
Yes. Yes. Tell me.
x square plus l square by 4 raised to 3 by 2?
Maybe. So first of all, what I'll do is I'll take an elementary, right? So let me. Am I audible to you guys?
Yes, sir, you are. Oh, but this answering is lambda. We have given sigma, right? Not lambda.
Yeah.
Okay, so I got it.
So if you do this again elementary thing, you're supposed to find the. Okay, let me do it separately, not to confuse. So what you can do is you can move x and cut dx. Now, what you're cutting is not a point charge, it's a line actually. It's an infinite line. And therefore, the electric field of the infinite line at the point P will be like this. Now, because of symmetricity, I can take this as theta. And I can also call this distance as r as of now, which I'll convert. So what we are looking for is dy. Let's call it y. So we're looking for dy because the x will cancel out because of symmetricity. Given that x is also asymmetrical, I have to take dx separately and will integrate.
Yes, sir.
Okay. So now here we have d cos theta. What is d? The formula is 2k lambda by r. The simple cos theta. What is lambda now? Lambda is sigma dx
Yes.
into cos theta. And there are so many things. This question will be easy to solve in terms of theta. So I'll prefer writing in theta. R cos theta is h. So we can attach 2k sigma. And this becomes h sec theta. What about dx? It is going to be h sec square theta d theta and cos theta. And that's very much obvious. We have done this before. So tan theta is x upon h. So x is h tan theta. So dx will be h sec square theta d theta, and r cos theta is h itself. So r is h sec theta. Okay. So there should not be any confusion in what I have written. If you have, you can ask. So dy is h cancels. So cos into sec is 1. So okay, that's so simple answer. 2k sigma into d theta, right? That's it. Everything gets cancelled. So ey is how much? 2k sigma into theta. That's it. No theta. From where to where theta will be? Minus theta to plus alpha. Okay, you can make it alpha. Vector. I have taken alpha, alpha. So minus alpha to plus alpha, correct? Which is 4k sigma alpha, isn't it? Done. So ey turns out to be sigma upon pi epsilon naught into alpha.
But if we take in H and L, it will change, right?
Yeah. So now what is alpha? So we can say tan of alpha is L by 2h.
Uh,
Alpha is tan inverse L by 2h. Okay.
yeah.
So the ey in terms of L and h will be sigma by pi epsilon naught tan inverse of L by 2h. I hope this is clear.
Yes.
So of course, these are something which you need to practice. Don't just leave it as a my solution. Go home like at home after the lecture is over. Go through each derivation on your own till you realize it. It's not about knowing the answer. It's about can you realize it, feel it, and then leave it because you know how to do it again as and when required. Now, this is not only about electrostatics. Okay, what is interesting is that this is true about any chapter that will be followed further. So let's say a chapter like magnetism will have almost similar derivations, almost similar. The only thing is there we will be using the Biot-Savart law. Here we are using the Coulomb's law and its like derivatives. So elementary taken kind of question that I'm giving you here all are very much similar to the magnetism question. Once you have the habit of doing the integration here, automatically you will feel comfortable with the magnetism. Else, the situation remains the same. If you're not comfortable here, you won't be there as well, which is not a good thing. Okay. So I hope this is clear, guys.
Yes.
So let's go to the next derivation. Which is the electric field due to uniformly charged circular arc at its center of curvature. At its center of curvature. We are supposed to find the electric field at this point. Let's draw the any arc. We do not want complete one, we just want some part of it. That's why I'm saying arc. So we have a circular arc, and this arc subtends an angle alpha at its center of curvature. Lambda is the again linear charge density. R is the radius, and we are trying to find the electric field at the point O. Now again, there is a symmetricity for sure, and what we can always say with surety that the resultant field always follows the line of symmetricity. So the net field is going to be like this, downward arch. So how to take the elemental? Definitely you should move some angle theta away from the line of symmetry and then cut d theta, then find the d, then take the component in the bottom direction, which is let's call it y, and then integrate to get the answer. So this is now so simple that I expect all of you to be able to do this. So try this out, take elementary, think about how to take elementary, which is the logical way of thinking, logical way of taking the elementary, take it and solve it. Okay. So please go ahead, everyone.
Hello.
Yes.
2k lambda by r sine alpha by.
Yeah. How much? 2K?
2k lambda by r
Yes.
Sine alpha by 2.
Very good. And again, you can see the answer is just like angle bisector.
Ah.
So technically, there is no difference. The D has been replaced by R, and it is still the angle subtended by 2. So that's why whether we have the line charge or we have the circular arc, there is something really interesting about the relationship. What really matters is the perpendicular distance, and we know here the R is the perpendicular distance from the O to the circle. So D is replaced by definitely R, and the answer is still the same, sine alpha by 2. Okay, okay, it is clear.
Yes.
So let me show you something interesting. What I'll do is small trick. So we have a rod, you can see, which is just touching the circle. Like the lambda here is minus lambda, here is plus lambda. So what will be the electric field at O? R is the radius. So the electric field at O will be how much?
What is it? Plus lambda minus lambda.
The circle will have the positive charge density, and the line touching the circle will have negative charge density.
What did we say?
It was zero, no? Because one is positive, other is negative.
Yes.
Answer will be zero.
Zero.
Okay. So now what we are going to do, we're going to extend this idea for quarter and semicircular arc. So this is particularly very famous question. And again, this answer is something which you can remember. But no matter what we can say for sure that every arc will have every arc will have some symmetry, and the net field will be along the line of symmetry. Okay. So if this is the positive arc, then the net field will be going to be exactly the angle bisector, correct?
So root 2 k lambda max.
Yeah. So of course this is root 2 k lambda by r. So for this particular case, can we say the value of this component and this component will be same? So both components are going to be
Yes,
equal
k
k
lambda
lambda by
by r.
r. And this is exactly the scenario with the semi-infinite wire k lambda by r, right? So there is a relationship like if we have quarter ring, every component is going to be equal. For the obvious reason, it's 45 degree, which means the two vectors are equal, and the answer is also easy to remember, k lambda by r. So what if we have a half ring? So if we have half ring, so you can think as a two-quarter ring, right? So if you think of the first right quarter, the field will be where the right quarter will create a field like this, which means it will have two components left and down, correct?
Both will have down component in same direction.
Yeah. So the component left and down, we can do it like this, and then for the left one, the left quarter, it will be right and down.
Yes.
So for sure, you can see that the right and left cancel out, right? So this we call just a E naught, or you can just call it E naught because that's easy to remember. So this is E naught. So this is also E naught. This will become 2 E naught. So we can say EY is, or you can say EO, the net value. So the net value at O will be how much? 2 due to, that's confusing. Okay. Let me change the sign. Okay, let me call it E only, not to be confused. So where E is what? E is component of E due to 1/4 of ring. Okay, anyway, so the EO turns out to be twice of E, and the E is k lambda by r, the simple answer. And the formula will give you the same answer, which is 2k lambda by r sine
180
180 by 2. So anyway, no matter what we choose to write, you end up getting the same answer. So now component method is really interesting. It gives you some visualization, what could be possible, what could not be possible. And we can play some around with some of these questions like this. Maybe next page. Um, Let's say what I do is just for the sake of change, the half of the ring is positive charge and the half is negatively charged. The lambda is same, so value is not different, only the sign is different. And now again, I would like to find the electric field at O. So now the positive one will repel, right? If you imagine a positive charge,
So it will be 0.
be very careful what you say, because it's a vector quantity. How it will be 0? So this will create a field like this at bisector, correct? So one field is like bisector repulsion. The negative will create the field towards itself, right? But it will be also bisector, isn't it? So the net field of the left quarter and the net field of the right quarter both will be same, no? Numerically. And this is 45, this is also 45. So the resultant of these two will be in which direction? Or you can think, even if you want to think this, the change of sign will change the orientation, right? So the left quarter will create the field like this, right and down. Is clear? But the right will attract. So how to find the field direction? You put a positive charge and you see the force of interaction. You see the attraction or repulsion. So the right will either pull up or it will pull like this. Do you realize this part? And you can see that up and down will cancel out, and what will left with is twice of the one of the component. So the answer is still the same, 2k lambda by r, but in which direction? X direction. Earlier it was in the downward direction. Is this clear? Is this clear, guys?
Yes.
Okay.
Yes, sir.
So sometimes you may get a question of a variable lambda. If lambda is variable, what will happen? So lambda is given as a function of theta from the positive x-axis, and what is given that lambda is equals to lambda not cos. The first question is, what will be the direction of E at O? So first, can you guess the direction? And then find the magnitude of E vector at O. So these are the two questions that you are supposed to solve now. Yes.
Sir, I'm getting the answer as K lambda naught by R.
Okay. Okay, that's the
K,
answer.
no, more pi by 2.
Five. Let me check. So again, first of all, okay, to do this problem, you need to have some idea about the trigonometry. So if you plot the graph of cos theta versus theta, we know the cos will be positive in the first quadrant, right?
Yes.
So although the charge is non-uniform, but it is still symmetric with opposite polarity. And therefore, the net field is going to be towards left for sure, right? Do you realize this part? Hopefully, no, you don't realize. If I take a theta here, if the charge is positive here, we can get exactly a negative charge here.
Yes.
Yes.
So if this will push the point O, if you put some plus charge here, so this will repel. So the field of the plus is like this, and the field of minus will be like this. And so the net will be towards left. So the first idea that we can understand is that the only field which will exist is the x component, not the y component.
Yeah.
That's the first idea. If we have the first idea, we can go to the next idea. But what if the idea is not there? Can you solve the question without the idea? The answer is yes, you can solve. But it will be just one extra calculation will be there. And what is that? Let's check it out. Let me move this part. So I'll solve here. So now what we do is again the same. We take elementary. So let's say we move theta and we move d theta further. If this is theta and if this is d theta, the elementary is this and the field will be like this. This is the dE vector or dE symbol. Okay. So now this is the dQ part. This part is your dQ. Okay. Let me move this. And writing the d is quite easy, right?
Yes.
It's k dQ by r square.
Yeah.
That's
And DQ we can write in terms of
and dQ
alpha.
current is lambda dl
DL is R.
and the dl is r d theta.
And lambda is lambda naught. First.
Right. So lambda not cos theta into d theta by r. One r gets cancelled, right?
Yes, correct.
And now this is not the end. What we are looking for is only
One.
dx. Okay,
Yes.
let's say someone is not able to understand that I need to find dx or dy. In such scenario, find both. Simple. And one of the component will become zero automatically.
Sir, I checked both and then I understood. Yeah.
So the dx will be how much? Or if you want, you can
First.
simply write the dE vector will be dE cos theta minus I cap and dE sin theta minus j cap. You can also write like this. All are the possible ways of writing. And then you integrate. Okay, so you just integrate and you end up getting the answer. So the d cos theta, d is what? Okay, we have the answer. So cos and cos becomes cos square, right?
Now double line.
So the cos square theta, d theta minus I cap, and then the other we can write as sine theta into cos theta, which will highlight as sine 2 theta d theta. Just by manipulation, I put 2 here so that I can have 2 sine into cos, and sine into cos uh, from 0 to pi will be always 0. This is always going to be 0. For the obvious reason, the time period of sine 2 theta is pi 1. Correct? In one time period, you have 0 oscillation. Right? I hope you understand the area under the curve.
Yes. It will
And
be equal to 0.
yeah, so now this part is cos square theta from 0 to pi. You can integrate by writing 1
Cos
plus
2
cos
theta. 2 theta
by
by
2.
yeah.
And again cos 2 theta integration will become 0. Only pi will be the answer.
Yeah. Or
So
pi by
yeah, your answer is correct.
ah,
K lambda not pi by 2r is the right answer. Very good. Excellent. So these are the ways of solving the questions when lambda is variable or lambda is constant. And then the third variety of question that you will come across is called the combination of the two, like the circular arc and the line charges joined together. And then they will ask you the question to solve. That we'll do in the next lecture. So with this, we'll stop today's lecture. Also, we are at the last page of the Zoom. I cannot write further. And in the next lecture, what we're going to do, of course, we'll do some more derivations and we'll introduce the electric field lines concept very soon.
so next lecture I will not be there.
I know. Don't
Yes.
worry. You enjoy the moment. And you can
Yes.
have the recording and you can comment. Okay. You can watch through the
Yes, sir.
recording. So bye guys. Take care.
Thank
See
you,
you
sir.
in the next lecture.
Bye.